All right, in this video, I'm going to talk about the addition of Grignard reagents to carboxylic acid derivatives. And you guys already know this, all right? We've talked about it a little bit in chapter 12, that if you add, so if you go back to chapter 12, in making alcohols, if you add a carboxylic acid, or esters, I think they only talk about esters, the book only talks about esters in chapter 12. But if you add a Grignard to an ester, it adds twice. And that's going to be true for every carboxylic acid derivative. And so let's look at how that happens. So again, let's use the ethyl acetate we made in the Fischer esterification. We're going to use two equivalents. Let's use phenyl Grignard here. So two equivalents of phenyl Grignard, and then we're going to follow up in a second step with water. This step's just got to protonate the O- at the end. So it can be HCl, it can be whatever. Okay, so phenyl Grignard is going to react like phenyl minus. It adds in. Remember, a Grignard is basic, so we can't have any strong acids, and the nucleophile is going to attack first. So the nucleophile attacks, and this is irreversible. This is a completely irreversible step. Why do I say that? Well, in the reactants, you've got a carbon minus, super strong base. You make an O minus. All right, so in principle, the O minus can kick out a C minus, like you could draw the arrows. But an O minus is it's a strong base, but it's like hydroxide, right? It's not a crazy base. A carbon minus is a crazy base, and so this is never going to go backwards. But what can happen? So in an aldehyde or a ketone, you're stuck here, right? So if we add a Grignard to acetone, well, let's say acid aldehyde, right? If we add to an aldehyde, we've got a methyl can't leave. Methyl minus is a super strong base. Phenyl minus is a super strong base. And H minus is a super strong base. There's no leaving group, we're done. Here, O minus can put the charge on O minus, so we can kick out the leaving group, right? If X is not carbon or hydrogen, it can be kicked out, it can be a leaving group. And so this actually is an equilibrium. And what it does is it makes a ketone. Okay? You'll recall from chapter 19, ketones and aldehydes react with nucleophiles faster than esters. So this would be relatively slow, and then this would be relatively fast. Let me draw that ethoxide somewhere else. Okay, there's no way to say just add the Grignard into the ester, but not add it in, but stop it before it adds into the ketone. You might say, well, what if you only add one equivalent? If you only add one equivalent, a little bit of the ester will react, and then immediately it reacts with the ketone that you get immediately reacts with the Grignard. If we use one equivalent, what we'll get is 50% this and 50% ester that's unreacted. All right, so it's been tried, can't do it. So the only way to add a Grignard to a carboxylic acid derivative is to add it twice, right? And then this is the product of step 1, H2O in step 2, O minus grabs that H. And so you wind up with an alcohol that has added the Grignard 2 times, right? So phenyl Grignard, you got to have 2 phenols on what used to be the carbonyl carbon. And then when we protonate it, when we add in water, we'll also get ethanol. All right, so again, anytime you have a carboxylic acid derivative and you add a Grignard, the Grignard's going to add 2 times. There's no way to only add it once, even if you really want to. So the way to only add it, well, we'll talk about that in class today. And then you're going to end up with an alcohol that's got 2 equivalents of the Grignard. You can't add 2 different Grignards in this process, right? We couldn't have phenyl Grignard and then like ethyl Grignard, because you don't know which one's going to add when. Okay.